The most common example we have of acceleration is that of constant acceleration. In this scenario, we have a series of equations that we use in order to determine what the position, velocity, and acceleration is by having these sets of equations that we can use whenever we find a scenario when acceleration is constant. These I oftentimes refer to as the kinematics equations. Here are the three kinematics equations that I'm referring to. All three of these are in your reference tables. You'll notice that they've been written with position as being x instead of being d. The first one being velocity is equal to initial velocity plus acceleration times time. The second one being position is equal to initial position plus velocity initial times time plus 1/2 at squared. We already addressed earlier how these two are actually the velocity one is a derivative of the position one. The final one is velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. Position minus initial position in this last term right here, that is displacement. Anytime you find that you have a scenario where they tell you acceleration is constant, you can use any of these three equations to find some unknown kinematics value. The last thing I want to talk about within this unit, or within this topic, is A1 free fall. When you have an object that is in free fall near the Earth's surface, you'll find that the object is falling with a constant acceleration. So all those equations we just talked about can be in play here. In AP Physics, we use acceleration due to gravity to be 9.8 meters per second squared. Note that this is different than what we did in honors physics, where we used 9.81 meters per second squared. The differences are minute, but I want you to make sure that you're using the right constants. That constant, 9.8 meters per second squared, is on the first page of your AP Physics reference tables. When you talk about free fall and the acceleration there that derives from it is caused by the gravitational attraction of Earth. Last year in honors physics, we talked about Newton's law of universal gravitation. Part of that is acceleration due to gravity. When we talk about the symbol used for acceleration due to gravity, the symbol used is the lowercase g. So this symbol is used for acceleration due to gravity in all our examples. And again, that is 9.8 meters per second squared. The thing you have to realize is that that is during the absence of any air resistance. If you have any air resistance, what you're going to find is that the 9.8 meters per second squared will always decrease in magnitude, meaning that if the air is pushing on it, it's adding a force. That force is going to take something off the acceleration. So in the presence of air resistance, you're not going to quite see 9.8 meters per second squared. You'll see a little bit less. Ultimately, the amount of air resistance always increases with the speed of the object. So as an object goes quicker and faster, it encounters more air resistance. This example, I would like you to try in your notes right now. It talks about a ball being thrown straight up with a speed of 12 meters per second from a window that is 10 meters above the ground. I want to know a couple different things. You can see this in your notes. What I'm asking you for is how long does it take to reach its maximum height? How long or what maximum height does it reach? And what speed does it hit the ground with? Please note that I do have a typo in here. It's not 12 meters per second squared. It's 12 meters per second. And I want to refresh your memory about something we talked about in honors physics, and that is there's a couple things about free fall questions that you need to keep in mind. When you hit the peak, which I'm asking questions about the peak, recall that the velocity when it hits its peak is 0. That's very important in this problem. If you recall that, and that there's symmetry between the upward path and the downward path, those are the things that we talked about in honors physics that you want to apply here. So go ahead, fill this out on your note packet. After you do, just go to the next slide, and I will solve this question for you so you can check against your own work.